Hormones that change systemic vascular resistance must have an impact on the diameter of the blood vessels that we have. The hormone molecules that are released into bloodstream must change the diameter of the blood vessels that we have, especially in skin and abdominal viscera. For example, when these hormones make the arterioles that we have in skin and abdominal viscera to constrict, we know that constriction of so many arterioles increases systemic vascular resistance. And we know if systemic vascular resistance increases, blood pressure would increase. However, let's note that it's not just about changing the diameter of arterioles, because if a hormone makes veins and venules to constrict, these veins and venules push more blood toward the heart. Basically, venous return, the amount of blood that veins bring back to the heart would increase, and we know if heart receives more blood, it pumps more blood out. So the conclusion is that cardiac output also increases. And we know that blood pressure, the average blood pressure, equals cardiac output times systemic vascular resistance. If cardiac output and systemic vascular resistance both increase, definitely the conclusion is that blood pressure increases. In this video, because we're trying to find those hormones that impact systemic vascular resistance, we follow the ones that change the diameter of arterioles. And we start with one of those very important hormones called antidiuretic hormone. Antidiuretic hormone is produced by neurosecretory cells that we have in hypothalamus. However, it is released into bloodstream in the posterior of pituitary gland. And antidiuretic hormone is one of those hormones that targets the arterioles that we have in skin and abdominal viscera, make them constrict to increase systemic vascular resistance. We already know that a very low blood pressure would be considered emergency, because if blood pressure keeps dropping and nervous system and endocrine system do not quickly bring the blood pressure back up, a very low blood pressure results in a very slow blood flow. It simply means that many of our important organs might not receive oxygenated blood on time. That's why when blood pressure is low, the sympathetic nerves fire signals, including thoracic spinal nerves that stimulate adrenal medulla. And we know that the result would be secretion of epinephrine and norepinephrine from adrenal medulla. These two hormones also target the arterioles that we have in skin and abdominal viscera. By constricting these arterioles, they also lead to an increased systemic vascular resistance to increase the blood pressure. Aside from antidiuretic hormone, epinephrine and norepinephrine, we have another hormone named angiotensin II. This one also can cause constriction of the arterioles in skin and abdominal viscera to increase systemic vascular resistance and increase the blood pressure. Recall that angiotensin II forms when angiotensin converting enzyme in our blood capillaries, especially in the capillaries that we have in lungs, changes angiotensin I to angiotensin II. So now we have 4 different hormones that all 4 of them increase systemic vascular resistance. However, let's pay attention that these are not the only hormones that change systemic vascular resistance, because if blood pressure is higher than what is acceptable, the atrial walls stretch, and quickly the cells that we have in atrial wall secrete a hormone named atrial natriuretic peptide. Clearly, when we say this hormone is released when blood pressure is high, the goal would be to decrease the blood pressure. So when we follow atrial natriuretic peptide, we see that it targets the arterioles that we have in skin and abdominal viscera. However, this hormone makes those arterioles to dilate. And we know that when all these arterioles dilate, systemic vascular resistance decreases, which that leads to a decreased blood pressure. So in this video, I talked about a total of 5 different hormones that they all impact systemic vascular resistance. 4 of them increase the vascular resistance, and the last one decreases systemic vascular resistance.